Okay, now I think I have it. Okay, right. So you guys
Yes.
can hear me, right? And record. That's great. Okay. Apologies for the delay. Let's waste no more time. Okay. Okay. So we were discussing. Okay, last time what we discussed was a little bit of network architecture. Okay. So I told you that what are the basic architecture of 2G, for 3G, and 4G. Some few nodes were missing. I added those. I added DNS, how DNS is connected. I added how charging gateway is connected, and added how OCS is connected. Next, we had a look into the different interfaces. The basic interfaces of 2G, 3G usually have common interfaces. Only IU interface is a little bit different. Other than that, the basic core interfaces are the same. And then there are different interfaces in 4G network architecture, where only the OCS and PCRF interfaces are the same. The rest of interfaces have been renamed and the protocols are a little bit of different. Okay. And then we had a little bit of look into how roaming works. So your serving gateway connects to your roamer PDN gateway, and it is vice versa. If you're going on outbound roaming, then their SGW and SGSN connects to your local PDN gateway or GGSN. Functions of different NEs, I have updated this. You guys can have a look at this afterwards. So basic function of SGSN: mobility management, session management, routing and transfer packet, and charging. For GGSN is session management, routing and transfer, and it is charging. For charging gateway, it's real-time collection of CDRs. It stores the CDRs, it pre-processes the CDRs, and it then sends the CDR, or the billing center fetches the CDRs from charging.
Sir, there are two DNS. One is used for
Yes, there are two DNS.
mean one APN resolve, one DNS used for APN resolve and one DNS for normal
Yes.
URL. Okay, fine.
Yes, there are two. Okay, so we'll come to DNS. Then we have HLR. HLR is responsible for authentication center. It has your subscription information. It is used in authentication, and it provides your location information to the SGSN when and whether it is required. DNS. One functionality of the DNS, which is your internal DNS, that is responsible for providing your GGSN IP address against an APN. It is responsible for providing SGSN IP address, which we will see have a little bit of more understanding how it works in the intra-SGSN routing area update, and it provides the RNC ID, the SGSN IP against the RNC ID when we have the relocation procedure. The other DNS is your external DNS that is responsible for providing the IP address against the different URLs which you browse. You have youtube.com, you have facebook.com, yahoo.com. So all these have a backend IP address. So resolving that into an IP address is a functionality of our external DNS. Border gateway is used in your roaming, and border gateway is basically a gateway. It is a gateway that is installed on the border of your network. So it's responsibility that any traffic that is going from outside your network and needs to access some other PMLN network, it needs to go through your border gateway. So it has some security protocol to ensure that there is no one is illegally accessing your network, and then there are some routing protocol that ensure that your traffic is or your request is correctly routed to the proper network on whom you're trying to access the service. Mobility management entity response. This is basically an equivalent of SGSN, but only the signaling part. So, or the signaling part in the 4G network from SGSN is performed by your mobility management entity, where SGW is basically your user plane part of your SGSN as well as GGSN. In GGSN, it is responsible for GGSN's functionality is divided into two parts. Some portion is in SGW, which handles your user plane traffic, and the other part is basically the IP address allocation communication with OCS, PCRF, your DPI on that. So that is all part of PGW. Okay, or your AMBR, GBR, DHCP server, uh, IP allocation, routing, DPI, communication OCS. So that is all part of your PGW. Okay, these are some protocol documentation of 3GPP if you guys are interested, because this is a basic level training. So if you want a little bit more depth into this, so these are some protocols of the 3GPP documentation. So you can search these; they are freely available on the internet, and then you can browse through these documents. These have an elaborative description of your NEs, your call flows, how an NE perform, how your call flows are done, and the exact signaling, what is contained in that. So all this is information. So the first three are related to 2G, 3G. The fourth one is related to 4G or LTE. Okay. So before we move towards our call flows, there are some timers which you must know about. So, and these are usually defined in SGSN or your MME, and these are called mobility management timers. So the first one is your periodic routing area update timer. This is a timer that is assigned when you get attached to a network. This timer is assigned to you, and what it ensures is that after a specific amount of time, you need to update your location to the SGSN. So that is called a periodic routing area update. Even usually routing area update is done when you change your routing area, but even if you're in the same routing area, you are forced by the network to share your updated location. So that is done via periodic routing area update flow. And the length of this timer is assigned in the SGSN. Usually it is 54 minutes. But the standard which is defined is, so after every 54 minutes, you will always send a periodic routing area update timer. Okay, a few of the colleagues are saying that they cannot join the meeting. Wait, let me just inform them. Let me just forward them the link. Okay. The other one is mobile reachable timer flag. You must know the MN. So this timer is the value of this timer is greater than the periodic routing area update, and this is basically a timer which is assigned to your. It is basically not assigned to your MSID. This is configured in the SGSN, and this timer ensures that whether the mobile is reachable or not. So if a mobile does not send a periodic routing area update in 54 minutes, and then the extra amount of time passes, then then SGSN realizes that this handset or this MSIDN is not reachable, so it turns its state to standby in 2G and PMM idle in it's sets you to detach state. Okay. And if you send a routing area update afterwards, or you send an attached to service request afterwards, so your status is inverted. And as I clarified that this timer needs to be longer than your periodic routing area update timer used by the MS. The standard value of this timer is 58 minutes. So in 58 minutes, if your handset, if you do not send a periodic routing area update timer, then SGSN realizes that you are detached and you are not available for the network, and then it sets its state as detached in the SGSN as well. The last timer is the purge timer. This timer, because even if SGSN sets your state as detached, it will still have your context available. It will still have your authentication sets available. So purge timer is a timer after which the SGSN removes all your user information from its database, and it also informs the HLR to remove all the SGSN related information and the PDB context information from itself. And this timer obviously is going is its value is greater than the mobile reachable timer function, and the usually value configured here is 24 hours. So 24 hours till 24 hours, there is no communication with the SGSN. SGSN will then purge your information from itself, and it will also ask HLR to purge all the information of this user from the HLR as well. So after authentication, you have your SGSN IP address, you have your SGSN GT and all that information. So all that information is purged. So you are not available to in HLR. Okay, Ryan is saying he cannot hear anything. Ryan, can you hear me now? Okay, so Ryan, I would suggest that you rejoin the meeting or maybe check your mic, your speaker, anything. Okay, shouldn't be an issue. Okay, so equivalent to this in 4G, as you'll I've been mentioning, it's SGSN. In 4G, there are equivalent timers. There are some more timers as well, like there is a paging response timer and all that, but those are not, those are a little bit advanced level. So basic level timer that you should know, being a basic PS4 understanding. So it's tracking area update timer. There is the same mobile reachable timer in 4G as well, and there is the purge timer function in 4G as well. There are some additional timers based on the additional flows, but the basic timers are the same. The tracking area update timer, I believe, is the same. It's configured as 54. The reachable timer is 58, and the purge timer is 24. But once again, this is something that is configurable. Okay. So next we will look at the mobility management flows for 2G and 3G. The first function that you come across, or if you go to any interview, is to explain the attach procedure. So we'll start with that. So what is an attach procedure? The attach procedure is basically it is used to perform an attach to SGSN. Your handset is here, and then you need to get attached to the SGSN in order to avail the data services. So you need to get attached to it. So in 2G, it's GPRS attached procedure. In 3G, it's UMTS attached procedure. The attached procedure in 2G, 3G are more or less the same. The 4G is a little bit extensive attached procedure. Okay. So if you look at the attached procedure flow, the MSSDN sends an attached request. In attached request, it can be an IMSI if you are attaching to the network for the very first time, or if you have been attached previously and you got detached, then you can send a PTMZ and a routing area ID. So what the new SDSN does is that if it is a new request, then this procedure number 2, 3 is not done. It will just go directly towards authentication. But if you were previously attached, then it will check that, okay, does it have your context available? If it does not have the context available, then based on your PTMZ and routing area ID, it will identify which old SDSN is it. Okay, so we will then go back. I will, like I explained to you, this thing, resolve the routing area ID to SDSN IP. So this is in inter SDSN as well, and this is in attach as well. If you got detached in one routing area ID, and then maybe you move to another city and then you try to attach. So in that case, it will go to the old SDSN, and based on your routing area ID and your PTMZ, it will identify the which old SDSN is it, and it will ask for the identification request that what is the IMSI of this MSSDN. If the old SDSN has that information, it will reply back with the IMSI, and then you will perform towards the authentication. In case that information is not contained in the old DSN as well, the information is purged. For example, 24 hours have been passed and all the context removed. In that case, the SGSN will then send an identity request to the MSSDN asking that, okay, you send me a PTMZ, but I do not have an IMSI against the PTMZ, so you need to send me the IMSI as well. So your handset will then send an identity response message where it will send an IMSI. Okay. IMSI. Next is your authentication part. Detailed we will cover in the next flow how authentication is done. Your SGSN sends your IMSI as part of your authentication to your HLR, and your HLR then send your authentication sets. The authentication sets 2G, 3G, 4G have different authentication sets. So HLR is going to send an authentication set to your SGSN. Then your SGSN is going to send some of those things to the MSIDN. Specifically, it sends your encryption key and the random number to the MSI. The MSIDN then calculates. Okay, so authentication, I think we can go a little bit further for you to understand. So this is how authentication works. The SGSN send authentication information to your HLR. HLR is going to respond back with your authentication keys. Then your SGSN is going to send the authentication and ciphering request to the MSSDN. MSSDN will do the computation and it will respond back with the response. And if the response received here and the key that is the response received in HLR, these are the same. In that case, your handset is authenticated and you're allowed to use the header services. In case it is different, in that case, that means that you're not authenticated, and then you will not be allowed to use header service, and you will not be attached. Okay. So the authentication keys that I was mentioning in 2G, there is triplet. You have a random number, you have a response key, and you have a ciphering key. In 3G, there are 5 different components of your authentication vector. You have a random number, you have an expected response, you have a ciphering key, you have an integrity key, and you have an authentication. And in APC, there are the 4 parts of your security vector. It's your random number, your authentication key, your expected response, and your KASME. KASME is basically a combination of your ciphering and your integrity key. Going a little bit of detailed into this. So what happens is that in this authentication and ciphering request, if you're talking about 2G, you send the random number and you send the KC, and the MSIDN computes the response and it sends the response, and then that response is compared with your SRES that is received from HLR. In case of 3G, you are sent the authentication, you are sent the AUTN, you are sent these keys, and you send your handle number. And here the SGSN in 2G, the SGSN authenticates the MSSDN. In 3G and 4G, as you can see, it's the bidirectional authentication. So MSSDN also has the capability of authenticating whether this request coming is from an authenticated network admin. So that is based on your AUTN key, authentication key. So MSSDN authenticates it. Okay, the authentication is fine. Then it will compute the response based on the random number, and it will install these CK and IK keys with it, and then it will respond back with the same response. And this response is then compared with the expected response. Okay, we will come to the process afterward. Okay, so it will respond back with the response, which is then compared with your expected response. If it is the same, then you're successfully authenticated. Okay, so going back to your authentication, right? Next is your IMEI check. This is if you have configured that you need to authenticate the handset, the IMEI as well. So you perform the IMEI check as well. So you get the IMEI. If it is not part of your attached request, you will ask the MSSDN to provide the IMEI. And this IMEI is then checked with the EIR over the GF interface to check whether this handset is not blacklisted or something like that. Once this is done, then you proceed towards your update location. So you send your location, your update location to the HLR. What is contained in this update location is the IP address of your SGSN and the GT of the SGSN. Okay. So this update location is sent to your HLR. In response to this, 6B and 6C is something that is optional. In case HLR has the old SGSN ID configured in it, placed in it, because you were previously sent to SGSN. So what SGSN is going to do is that it will send a cancel location to the old SGSN, and the old SGSN will send a cancel location to Alvin. And based on this, the old SGSN will remove all the context information from and all the authentication information that is stored in this old SGSN. And it will inform the HLR that, okay, I have cancelled the location, and then HLR will update the new SGSN location in its profile. And as a response to your update location, the HLR will send the insert subscription PETA. This insert subscription PETA is the provisioning information that is provisioned in the HLR against your MSSDN. So you have your quality of service information, or you have the different access points, your different APNs that you have subscribed to those APN. Those are configured in HLR. Then HLR shares those APNs to be stored in the SGSN. So the SGSN can perform the according routing, and the SGSN will send an acknowledgement of this, that okay, I have installed this subscription information, and based on that, the HLR will close this this communication by sending an update location acknowledgement. So once the profile is also saved in the SGSN, then SGSN will send an attach accept message to your MSSDN, and in this attach accept message, it will send an updated PTMZ. PTMZ is basically a temporary mobile subscription identity, because your IMSI is unique number that uniquely identifies your SIM. So that is not used for communication for security purposes. In your PS core, in your calls function, you have a TIMSI, temporary mobile, and in PS4 you have PTIMSI. It's a packet TIMSI. So in the attach accept, it will send a PTIMSI, so that the next communication that MSID run, that will be based on the PTIMSI, not on the IMSI. And the MSID then sends an attached complete message to the SGSN, so that it does not keep on sending this message again and again. Okay, so this is the basic flow of how your attach is done in 2G and 3G. And okay, so let's check into Yasser has a very big question. Yasser, okay, there were no IMSI in old SGSN. This is if your information has been purged. For example, 24 hours have passed and your data has been purged, so it will have no context information available. So in that case, it will not find anything in the old SGSN. Okay. I think somebody has answered that. This is what I'm asking. What is the MS should send IMSI then? Yes, yes. No, actually, MSSDN, look, MSSDN will have that. If I am once attached to the PS4 network, then I will have the PTMZ with me, irrespective of whether my data is purged in SGSN or not. I will have that PTMZ available with. So next time I initiate a request, I will always send the P. Maybe that PTMZ was assigned to me 1 week ago, so I will send the PTMZ. But SGSN, old SGSN will have my information purged, so it will ask me for an IMSI. The IMSI is usually sent when I don't have the PTMZ available with me. If my handset, different handset have different configurations. So if my handset does not have if my handset has also purged the PTMZ information from it, in that case, it will send an IMSI. Otherwise, it will always send the PTMZ that was assigned to me during my first attached request. Okay. Right. So after the end of the attach procedure, what happens? What happens is that the SGSN gets the subscription data from HLR, like your APNs, your quality of service information. Your HLR records the MS serving SGSN number. So SGSN number is GT of the SGSN and the IP of the SGSN recording the HLR. And your SGSN and MS create a mobility management context for the mobile station. So at the end of the that, a mobility management context is created in your SGSN. If you display your context, if you are using Huawei PS code is a command display MMCTX, so you will see that there is a mobility management context available with your current state, whether you are in ready state, attached state, idle state, whichever state. Okay, and after this, MS can request a session management services, which is basically to use your browsing services different. This is a little bit of advanced level of attached procedure. You guys can look into it. It is the same one, but here it involves if you have a combined location update, combined attach, where you are getting attached to the MSC as well. So we can go through it a little bit briefly. We can go through it briefly. So in your step 1 to 4 is basically the same attach request, identification request, and your authentication. Then you have our IMEI check. And in case there was an old PDP session created, it will delete the old PDP. If your old SGSN had that, a PDP session created with the SGSN, so it will ask for delete PDP context. Then you have your update location, and based on that, you will get a cancel location of the old SGSN, cancel acknowledgement, insert subscription information in the HLR, and then you have an updated information that you will update the location in the HLR as well. Okay, and then you have location update accept, you have attach accept, and an attach complete message. So you guys can read this. This is a description of what I explained to you earlier. So you guys can have a look at it afterwards. Okay. The next is your authentication function. Authentication function is the same that I think we already studied this. How your authentication information is sent and how your authentication information is. Okay, how is PTMZ released? PTMZ is usually stored in the handset, and it depends on the handset that how it is going to be released. I mean, if there are some timers that are configured in your handset, in that case, it is going to delete your information. So that is configurable in the handset. I mean, not configured by us. It is configured by different mobile vendors. How they configure it, for how much time do they keep the PTMZ information. So that is proprietary of your handset. Okay, what is USN? Okay, that's a good question. Basically, since I have worked on Alcatel, and but majority of us are working in Huawei. So USN is basically the terminology that is used in Huawei for SGSN. Okay, it's the SGSN is called USN, the GGSN is called UGW. I think it's Universal Signaling Node and Universal Gateway Node. So this SGSN, GGSN, SGW, PGW, these are the 3GPP standard. So we use those, but when we go to a specific vendor, in that case, I mean, since we have been using this in with these terms for a long time, so it's sometime in delivering this information, I give that information. But USN is basically the terminology that is used for SGSN, and UGW is that is used for GGSN and Huawei. In Alcatel, it was SGSN, GGSN, and Huawei. In Nokia, I don't remember what we used to call different terminologies that were used in that. Yes, Talal has mentioned that it's a combined MME and SGSN. Yes, so if you include 4G, in 4G, it will have the MME functionality incorporated inside it as well. We looked at the security functions as well. Okay, so we have triplet, quintet, and 4 is, I think it's quadrets, something like that it's called. So 3 vectors here, 5 vectors here, and 4 vectors here. And KSME is a combination of KC and IC. Next is the detach procedure. Similar to what we have in attached procedure, we have a detach procedure as well. So the DPR detach procedure allows an MS to inform the network it does not want to access the SGSN base any longer. For example, if you turn off your data services, you will send a detach request informing that, okay, I don't want to use the data services. And vice versa, if SGSN wants to detach you, it will allow the network to inform that, okay, I cannot no longer serve you. I am detaching you so that you cannot use the data services any longer. So there are 3 entities that can initiate it. You can the MSISDN can initiate it, the SGSN can initiate it, and then HLR also has the ability to initiate a detach procedure. We'll have a quick look into the flow. So if the MSISDN is initiating a detach, for example, you are using 2G, 3G, and you turn your data services off. So you will send a detach request to the SGSN. The SGSN will realize that, okay, you have, if you have any PDP contacts created, so it will send a delete PDP context to the GGSN. So the GGSN removes the PDP context from it, and it will respond back with the delete PDP context response. What is this PDP context? We will look into it afterwards in the next few slides, where we will cover the session management flows. So delete PDP context response, GGSN removes all the information, and then SGSN will remove the context information, and then SGSN will send a detach accept message to the MSISDN. And then if there is any signaling connection between your MSISDN and your radio and radio SGSN, that is also released. So at the end of it, user is detached. The other is SGSN initiated detach. How this is done? If you are logged into SGSN, you have the option of removing a user. Okay, so you can delete a user, you can remove a user, you have a command to that, and when you execute that command, you initiate a detach request sending the MSIDN that, okay, I am detaching you. And based on that, if you have any context created, it will initiate a delete PDP context with GGSN as well. GGSN will remove the context information, respond back, and then you will, and if I mean, if you have any, if you had a combined location update enabled, then you will indicate to MSC as well. But this is a little, this is usually not used in 2G, 3G. So you will send an indication to the MSC as well. And based on that, your MSSDN will detach and it will send a detach accept message to your SGSN. And then if there is any connection, signaling connection available, the signaling connection is going to be released. Based on this detach request, I believe the MSSDN will remove the PTMZ. But once again, this is what I believe, what I understand is that this is configurable on your handset. So in case of detach request, maybe your PTMZ gets removed as well, but I think this is configurable in your handsets. The third one is your HLR initiated. So in HLR initiated, those who are working in the packet core, you must be knowing that when you perform the roaming testing before you have your roaming agreement, you perform some roaming testing with the SIM. So this is a scenario which we frequently use. In that roaming scenario, you have a okay, you perform the attach, you perform the PDP, and you perform the browsing, and then there is a functionality that okay, you need to perform barring on the HLR. So when you perform the barring on the HLR, HLR sends a cancel location as well. So you enable a trace, and you can see that okay, when HLR performs barring and it sends a cancel location. So based on that, then you will not be able to attach your network. You perform successful attach using the roaming SIM. So in that case, or for any other scenario, you ask the HLR team to cancel your location. So HLR has the option of sending a cancel location. So HLR will send a cancel location in the SGSN. Based on that, the SGSN will send a detach request to your MSSD, and it will delete the PDP context and it will send a detach accept. And once this is done, then SGSN will inform that okay, your location has been cancelled. So cancel location update, and based on this, HLR is going to purge all the information available with it for this MSSDN available. Okay, and then if there is any signaling connection available, that signaling connection is going to be released. Okay, so at the end of the detach procedure, what happens? SGSN shall not serve the detached MS and unless reattached. So unless your MS IDN sends an attach request again, it will not serve the detached, and your mobile station gets into your PMM detached or in the idle state in 2G, and in 3G you go into PMM detached state. So based on that, unless and unless an attach request, you will not be able to use the data services. When you get detached, you will frequently come across these two terms. What is explicit detach? What is implicit detach? So explicit detach is when your network and your MSSDN both have the detach information available. If you this is usually used when you detach your number from SGSN. So once you detach it from your SGSN, you have the option of selecting whether it should be an explicit detach or implicit detach. An explicit detach, you will delete the context information, you will delete the user information, and you will also inform the MSSDN. In implicit detach, you will detach the network, you will detach the MSSDN, but you will not inform the mobile station. Okay, this is usually done when your mobile reachable timer has expired, or there is an radio connection issue based on which your detach request is not used. So MSIDN thinks that I am still attached to the SGSN, and SGSN does not have that information. So your routing area update. So if MSIDN sends a routing area update that is going to be rejected, then you have to perform a new attach request. So explicit means that it is detached in both MSIDN as well as the network, and implicit is that it is only detached in the network and not in the MSIDN. Homer, PS signaling connection is basically a signaling. I mean, when you have a handset, your handset will get connected to your BSS system, and your BSS system, from BSS system you'll connect to the SGSN. So there is a logical link. There is not a physical link, a wireless link that is connecting your MSIDN to your SGSN via your BSS or your node B. So that is a PS signaling connection. We will come to it once we check that the PDP connection flows, I will explain to it a little bit more, that once your PDP is connected, or even if you get attached, you have a link available based on which you will send your routing area update request, based on which you will send your periodic routing area. So that is a signaling that is similar to your CS core signaling, based on which you send your location area update, your page. So that is a connection that is established between your MSID and SGSN after the attach request. So if we are talking about connection release, so that connection is released once you're detached, because since you are detached, so there is no need for you to have a signaling connection with the SGSN. So that connection gets released. Okay. SGSN can initiate detach without any command. So you will doing okay. SGSN can initiate a detach. This detach is initiated when your mobile reachable flag is expired. You know, a timer, the MN, the mobile reachable timer flag. So if your that flag, that timer is exceeded, in that case, SGSN can detach you. The other thing is that you can do it via a command as well. Okay, the next flow that we are going to look after is the routing area update procedure. Okay, so before going to this, I will come to this slide. Okay, so what happens is that your MSISDN, if you have an active handset available, you will be connected to a cell. Cell is a mobile tower in which you get connected. That cell is part of a routing area. Similar to your location area, in PS core we have routing area. So each routing area will have numerous cells that are part of it. So cell 1, cell 2, cell 3. So all these are part of one routing area ID. So if you are attached to this routing area ID and you are then traveling and then you move to this routing area ID, so your routing area ID is going to be changed. So if you remember, I mentioned you that there are two types of routing area. One is the periodic routing area, which is that you stay in this routing area, but 54 minutes have passed. In that case, you will send a periodic routing area and will send the same information. Okay, this is the same routing, so SGSN will have this information. Okay, this MSGSN has this routing area available. But if case you are moving the routing area ID, then the specific tower or the cell that you are connected to, that is continuously propagating the routing area information. So your handset realizes, okay, previous routing area was different. Now what I'm getting is a different routing area. So now it's my responsibility to send a routing area update to SGSN to inform SGSN that my location has changed. Okay, so if I'm using the word location, what I mean to say is routing area. Okay, it do not confuse it with the location area ID, that is a CS core, but in packet core terminology, the location area is routing area. So if my location is changed, I need to inform the SGSN, because if you remember, one of the functionality of the SGSN was mobility management. It tracks your mobility. It keeps a track on your location. So I need to inform SGSN that, okay, my location has changed. So that is what is called an routing area update. Yes, Umar? You can type your.
Usman, I
Yes.
just want to ask one question.
Yes.
Like in routing area identity is a combination of some lag or tag, or it's just a simple number that is assigned to
Routing area ID is MNC plus MCC plus routing area ID. So when you have a routing area ID, it will be for, like, if you're working in Jazz, it's 41001, and then there is going to be a number. So in this terminology, the whole terminology includes of MNC, MCC plus routing area ID. Okay, so it will be like this: the MNC plus MCC plus the actual routing area ID. Yes, slack and rack. And routing area ID is basically your location area code plus your routing area code. Great. Thank you. Okay, so if you are moving in the routing area ID from one routing area to the other routing area, but it's covered in the same SGSN, it's called intra SGSN, within the same SGSN routing area update. But if you are moving from routing area to another routing area, and that routing area is covered in another SGSN, then that is going to be known as an inter SGSN routing area update. So intra is a very simple flow. Once I get to explain the inter-SGSN, you can easily understand how inter-SGSN works because it does not involve any complicated signaling or anything like that. Okay. So routing area update proceeds when you are entering a new routing area or if your periodic routing area update expires. Okay. So inter-SGSN routing area update, the new SGSN find the old SGSN from old RAI. This is based on the DNS. The old SGSN stop the downlink signaling, transfer the mobility management constant to the new SGSN, and your the PDU tunneling is transferred to your new SGSN, and your PDP contact needs to be updated to the GGSN to inform that okay, because all this is seamless. You will not observe that your routing area is changing and this is happening. So this has to be seamless. If you're browsing, your browsing needs to continue. You cannot expect the browsing to stop for a little bit. So you need to update your PDP contact as well if you're continuously browsing or streaming and you're changing your location. So this needs to be informed to the SGSN as well to ensure that there is a seamless handover from one SGSN to another. Okay, so in 2G, 2G, 3G, a little bit difference in that. So you send a routing area update request, and here you send your old routing area ID and your new routing area ID. So based on your old routing area ID, the new SGSN is going to identify the okay, what is the old SGSN from the DNS based on your old routing area ID, and it will send the context because your context previously was existing in this SGSN, and now you need to have the same context available in this. So it will send a context request, and the old SGSN will okay see that okay, I have received a context request, so I need to transfer all the context, all the information available with me to this SGSN. So it will send a context response message and transfer all the contact information to the SGSN. Then based on your configuration in your SGSN, if you need to perform the security functions, Khalid, you can type your question in the chat box and I will come to it after we complete this slide, okay? And I will answer that question. So you can send, so based on that, if your authentication is enabled, that okay, upon routing area update, you need to send your you need to perform authentication. So it will send it will perform your authentication for HLR and MSSDN, and then you will send an SGSN acknowledge, context acknowledge that okay, I have successfully received the acknowledge. If you don't send this, then old SGSN will keep on sending this contact message. There are a lot of signaling from available. Okay. And then based on that, if there are any packets that are available in SGSN that needed to be transferred to your MSSDN, those buffered packets will be sent to your new SGSN that okay, these are the packets that are available with me that have not been sent to this MSSDN. So now you need to send it to this MSSDN since you are the new SGSN. Since your SGSN has changed, it will send an update PDP context request to your GGSN informing that okay, any downlink communication that you had to do, you will not do with the old GGSN, old SGSN. You need now to communicate with the new SGSN. So new SGSN will send its IP address and its tunneling ID request to the GGSN as well. And based on that, the GGSN will update the information of the new SGSN and it will send a PDP context response to your new GGSN acknowledging that okay, I have updated this the new SGSN information available with me. Then you need to update the SGSN information to the HLR as well. So you will send an update location where you send the new SGSN GT and the new SGSN IP address. HLR will cancel the location in the old SGSN, and based on that, all your information or your authentication set, anything that is available in the SGSN will be removed. Acknowledgement of the cancel location to ensure that there is no continuous cancel location request that is coming. And then the new HLR will insert the subscription information of this number that is available to the new SGSN. The new SGSN will send an acknowledgement that okay, I have received the subscription information, and then HLR is going to send the update location acknowledgement acknowledging this request that okay, your update location procedure has been completed. 12 you can skip. This is where This is where you have a combined location update. We're not going to discuss this, a little bit of complicated procedure. We'll come to it afterwards. Okay, so we can skip 11 and 11, 12, and 13. So based on that, purely from packet core point of view, once your update location has been acknowledged, yeah, the SGSN is going to send a routing area update accept message to your MSISDN. It will allocate a new PTMZ, and then the handset is going to send in routing area update complete message indicating the routing area update has been completed. Okay. Right. So, right. Okay. How the SGSN have information for which old SGSN? If example, you have 4 SGSN. Okay. If you remember, when we discussed the DNS functionality, in DNS functionality, this thing, resolve routing area ID to SGSN IP address in enter SGSN. So what happens is that when you send a routing area update request, come back to here. Here you will have the old routing area information as well and the new routing area information as well. Based on the old routing area information, you have it configured in the SGSN that, okay, this routing area is not being served by me. So I will have its information available in my from the DNS or my DNS cache that is available with me. So based on that routing area ID, it will resolve it into old SGSN IP address, and then it will communicate with the old SGSN. Okay, so if you have 4 SGSNs available, this is, let's call this SGSN 2, this is SGSN 1, and then SGSN 3 and 4. So if the user was previously attached to SGSN 1, so its routing area ID was being served by this. Okay, so this is SGSN 1. So you are moving from this routing area to this routing area. So you were being served by this. So this routing area is served by this SGSN 1. So once you move to routing area ID 3, when you send a routing area update, you will have the routing area ID 2 with you in your message and the routing area ID 3 with you as well. So based on your routing area ID 2, this SGSN will recognize from the DNS that, okay, the previous SGSN that was handling was SGSN 1, so it will have this IP address available with it. Okay. Done? Okay. Okay. What is forward packet? Forward packet is basically if you are performing downloading, and if you're connected to 2G, you don't have that much of throughput available. So what happens is that your GGSN sends your messages to your SGSN, and your SGSN will keep those messages, and then it will also forward the messages to MSISDN. In case you perform a routing area update, and there are some buffered packets that are available in the old SGSN, so obviously the old SGSN will no longer have the communication with the MSISDN. So it will forward those packets to the new SGSN. Okay, these are some old packets or data, downlink data that are available will be, now it is your responsibility to send those packets to the MSISDN. So this is what the forwarding packet means, that if you have any buffered messages or you have any buffered signaling available with you that needs to be transmitted to the MSISDN, so it will now send it to the new SGSN to communicate with. Okay. So routing area update accept and routing area update complete. Okay. In 3G, the packet buffering, the main difference between 2G and 3G is that the downlink packets that are buffered are not buffered in the SGSN; those are buffered in your RNC. Once we will discuss the PDP context, I will introduce a concept of DT, the direct tunneling concept. In DT, what happens is that your RNC directly communicates with your GGSN. Your SGSN in your user plane, your SGSN is not involved. So GGSN will send the packets to your RNC, and RNC will buffer those, keep the packet, and then it will send the packet to the MSISDN based on what throughput is available and how much good of a signaling quality you have available. So the main difference here is basically this additional communication of SRNS data forward packet. So you send a routing area update request to your SGSN. SGSN will get the context information from the old SGSN, and then this old SGSN will get the context information from the old RNC as well. For example, you have a bearer ID, you have the details of the bearer, you have details of the context saved in the RNC as well. So you need to send this information to the new RNC as well. So you get the context information from the old RNC as well. It will send a response back with the context available, and then based on that, your old SGSN will send to the new SGSN the context information available with it, based on what is stored in the SGSN and what is stored in the RNC. Then you have your routine authentication, and authentication, after authentication, it will send that, okay, I have received this context information as well. Then, since I explained to you that your data, your downlink data is buffered in the RNC, so the old SGSN will inform the old RNC to send the packets that are buffered with you. So it will send an SRNS data forwarding command, and the old RNC will send the buffered packets to the old SGSN as well. And then this old SGSN will forward those packets to the new SGSN, because the new SGSN is now connected with this MSRDN. Okay, so this is a little bit of a little bit different from 2G inter-SGSN routing area update. Then you update your PDB context to GGSN, informing that SGSN has changed. You have its response. You will update your location to the HLR with a new information, the new SGSN GT and the IP address. It will cancel the old SGSN, and then once this has been done, your packets have been, so there is no need for the old RNC to have an IU connection available with MS. So it will send an IU release command. It will send an IU release complete, so that or your IU signaling that was created for this MSISDN between your RNC and your SGSN and your MSID and SGSN, that is released. So that is released, and your cancel location is acknowledged. Then you have your insert subscription information, its acknowledgement. Then this is for your combined location update. We can skip this part. And based on your update location acknowledgement, then it will send a routing area accept message and share a new PTMZ with this MSISDN and the updated routing area information available. And then it will send back with the routing area update complete message to indicate that, okay, I have received this. And based on this, your routing area update, inter-SGSN routing area update procedure is completed. Now, if we discuss the intra-SGSN routing area, you will see that a lot of signaling will not be involved. You will just send a routing area update request to this SGSN. It will realize that, okay, it's the same. It is the same routing area that is being covered by me. Then it was just going to send a routing area update accept message, and that's it. You won't have all this signaling. You don't need to inform the HLR. You don't need to perform any. You can perform authentication, but usually we do not enable this authentication. This is very frequently happening. You don't need to communicate with the old SGSN. We don't need to communicate with the old RNC. No need to update the GGSN. No need to update your location to HLR. There's no need to insert subscription. So all these messages are skipped. So it's a very pretty simple flow in case of intra-SGSN. Just an update request, maybe authentication and update response, and SGSN will note the updated routing area ID information. Okay, but the inter-SGSN is a bit complicated, so we covered that. If you can understand this, then you can easily understand how intra-SGSN routing area update works. Lal, what happens if new RNC is the same as the old RNC? It's intra-SGSN case. Okay, this is going to be the case of what I just explained. It is going to be the same. So this routing area is the same RNC. Okay, in case the RNC gets changed, then you have a relocation procedure between RNC to RNC. That is a little bit of complicated procedure. We will cover it a little bit later because it involves very sensitive signaling, and maybe the new engineers may not be able to understand. So inter-SGSN routing area and intra is at this level. I think this is enough for you to understand that, okay, from SGSN perspective, it is going, if both RNCs are being served by the same SGSN, it will be considered as intra-SGSN routing area. Okay, so 3G. Okay, service request procedure. Okay, so what happens in 3G is that you will understand this thing a little bit more when we come to the session management procedures. But what happens is that there are very limited number of radio resources that are available in your radio side in 3G. So if you're not communicating, for example, you have your data session activated and you are not performing any browsing. So what happens is that your signaling connection, your radio access bearer with your RNC gets removed because there are other users that are available that need to use that radio access bearer. So after a time of maybe it's a configurable time, it is okay. So can we configure two RAIs on two different SGSN? Okay, if RAI is the same and you configure on two different SGSN, this is a concept that happens in pooling. When we will discuss SGSN pooling and GGSN pooling, then I will explain that okay, if there is one routing area ID available, then this routing area will be defined in all of the SGSNs to ensure that there is no inter SGSN routing area update. Okay, so in that case we define all of that, but here when we are not using pooling, then one RAI is assigned to one SGSN. If we define it on two SGSNs, in that case and you don't have pooling available, then there is going to be signaling conflict and your KPI is going to get degraded. So if you have not used your services for a long time, like it's a configurable time, then your radio bearer gets uh, detached. Okay, and for you to I mean, if you finally decide that okay, I need to perform browsing, then you need to establish the radio access bearer, and that is done by a service request procedure. So this is only for 3G case. For active PDP contact request procedure for data transmission. Okay, so what happens is that your connection gets, as I explained, your connection gets because there are only limited number of sources available. So if you have a data connection available, but you're not using browsing, so your data, your session may be created between RNC and SGSN and SGSN and PGSN, but here it is going to be dropped. So when you decide to finally use a data connection, you will send an RRC connection request to the RNC, and RNC is then send an RRC connection setup request. Okay, so ensure that okay, your setup connection and then all the communication between RNC and MS is done in order to ensure that your RRC connection is established. Then you will send a service request message to SGSN. You will inform SGSN that okay, I need to establish a connection in order to use data services. Then you will have your security function. If it is enabled on SGSN that okay, based on service request, whether you need to authenticate or not. So this is optional. And based on that, you will have a service accept message. Then the SGSN is going to send a radio access, a RAB assignment request. So it will send a RAB assignment request instructing the RNC that okay, you need to establish a radio bearer with the MS ISDN, which was released previously. So so your RNC is going to set up a radio bearer request, and your radio bearer, once it is established between MSI and RNC, it will send a radio bearer setup complete message, and its response will be radio access bearer assignment response message. Here, it will give your RAB ID, radio access bearer ID is provided, and your RNC IP address is provided to your SGSN as well. And then there is your SGSN initiated PDP context notification. For example, the GGSN had a previous RAB ID available with it because GGSN will need to communicate with RNC. So if your RAB ID is changed, in that case, you will have a PDP contact modification where it will inform the GGSN that okay, the RAB ID has changed and maybe the RNC has changed as well. So your PDP modification is done. The GGSN is informed of the new radio bearer ID. And once that information is complete, then it is intimated to your MSSDN as well, and then MSSDN can successfully perform the uplink of packet at a unit that is the actual browsing. For your example, you need to check your email, you need to send an WhatsApp message. So based on this, once your radio setup is completed, your radio bearer is established, then you can send an uplink packet data unit to the GGSN to be communicated with your specific ISP. Okay. Conversely, service request is can be initiated by the network. For example, this involves the paging, your paging flow. For example, you are in a state where your radio signaling is not established and you have an incoming packet data. For example, you have an incoming email, you have an incoming WhatsApp message, you have an incoming video call, uh, something like that. Okay. So then SGSN will page this MSISDN, it will set a paging request. How this paging request and how does SGSN know where MSISDN is? This is the concept where your routing area ID comes. You know, you are performing the periodic routing area ID and enter. So after that, the SGSN has the updated location of the MSISDN available. So SGSN knows that which RNC I need to communicate to in order to page this MSISDN. So SGSN will send the page request to RNC, and RNC will send the paging request to your MSISDN. Based on that, it's the same procedure as this. The MSISDN will set up an RRC, the radio control connection request, then it will send a service request, authentication, then your RAB assignment is going to take place. So your radio access bearer is available to MSISDN. Then your SGSN initiated PDP notification if it is required. And then based on that, this downlink PDU, this downlink message that is available is then going to be transmitted to your MSISDN once you have a bearer established. So this is service request MS initiated, and this is basically network initiated, which is as a result of a paging incoming response, incoming request that is coming to a handset that is not in an active state. Okay, so these are the basic flows. The rest of the flows, if you need an understanding, you can share with me. I can add those, or otherwise I have shared you the 3GPP documentation. So there are many other flows available, but the basic level flow that you need to have a basic understanding of are these flows. So you can read these flows, and if you need help with the other, you can study the 3GPP documentation, or if you have any concern in that, you can correspond with me, and I will help to clarify any QA that you have. So next we come to the 4G mobility management flow. Let's keep a track of the time as well. Okay, it's 2:16. Okay, I think we will just be able to cover the mobility management. Session management we will cover in the next session. So in 4G mobility management, just like we discussed the ID, how routing area ID, which was clarified and explained by one of our colleagues. So in 4G, the location is a tracking area ID. And what is a tracking area ID? Tracking area ID is MNSO. Okay. So here the HLR have the database of all networks. So each chain need to include HLR to update. Yes. HLR has the database of an MSISDN, the provisioning information of the MSISDN. For example, if you activate your SIM, you go to any franchise and you say that, okay, I need to purchase a new SIM, they will give you a SIM. Then what they do is that they will allow the services, they will allow your CS services, they will allow your SMS services, they will allow your PS services, and they will allow your basic APN information. They will configure the APN information in the HLR as well. But the location information is not available in the HLR because your location is changing at all time. For example, you are in one city and then you're moving to another city. So once you perform your initial attached request or location update request, in that case, so some information is available in HLR at all times, like those information that is provisioned in the HLR, that is available HLR at all times. And that information that is informed to the HLR, for example, your location information, for example, your SGSN information, your SGSN IP address. So that information is updated at all times. So that needs to be updated to the HLR periodically based on your periodic routing area or tracking area update. So tracking area ID consists of MNC, MCC, and tracking area code. Okay. The other concept that we introduced here is, for example, in 2G, 3G, we had the packet temporary mobile subscriber identity. Here, the temporary identity that we use is called a globally unique temporary identity, GUTI. Okay. So you have MZ, this is fixed, MSIJ, that is fixed, and this is a temporary identity that is assigned to you. So what does GUTI consist of? It consists of GUMMEI plus MTMZ. Okay, so and what your GUMMEI is basically your MNC plus your MCC plus your MME ID. And what is MME ID? MME ID is basically MME group ID plus MME code. Group ID is basically when you are using MME pooling. If you are not using MME, for example, if you have an MME pool, if you have two pools available, you will give an MME group ID 1 to pool 1 and ID 2 to pool number 2. Okay, so that is used, and MME code is basically identifying the specific MME inside an MME pool. So if you don't have that available, so you have to configure each and everything that is going to be unique. So MNC, MME group ID, MME code plus MTMZ. So this is the component of your GUTI. And the location information inside your tracking area list is basically, you have one tracking area ID, and each tracking area ID will have multiple cells. So you are connected to a cell, multiple cells create to perform one tracking area ID. And then you have tracking area ID 2, tracking area, and then multiple tracking areas are configured inside the TLS. So here what we introduced is a tracking area list concept. In 2G, 3G, it was just routing area. One routing area, the other routing area. If you move from one routing area to another routing area, you will inform the SGSN that, okay, I have changed my routing area. In 4G, if you move between one tracking area to second tracking area ID, as long as you are inside a tracking area list, you will not inform the MME that your location has changed, because MME will have the information of your tracking area list. If it needs to page, it will page to your tracking, to all of the tracking areas in the tracking area list. So it basically decreases the signaling load. For example, you're moving from one tracking area to another, and what happens is that the coverage of a 4G cell is less. The radio guys would know this better, that if you have a 2G cell, it will have a large coverage area. For example, 20 kilometers or 15 kilometers. If you have a 3G cell, it will have a little bit of lesser coverage. And if you have a 4G cell, it will have even less coverage area. So if you keep on informing the MME whenever you change the tracking area, is going to be a huge signaling burden on the MME. So we introduce a concept of tracking area list to maintain that all the tracking area in one list. If you change your tracking area from one list to another list, in that case you need to inform the MME of a tracking area update. Otherwise, if you roam within a tracking area list, there isn't going to be any information that is going to be shared with any of your mobility management entity. Okay, so tracking area ID, MME ID, and GUTI. So there you used to send the PTMZ. Here you will send you are assigned a GUTI and you send a GUTI. Okay, location information storage. Here you don't have HLR. When you used to have HLR, if this information at this slide I didn't cover in 2G, 3G, so we'll have an equivalent information here. So in 2G, 3G, HLR, and you have the SGSN IP address. In 4G HSS, it will have the MME IP address. In 2G, 3G, you had your SGSN 1, SGSN 2. So you had your routing area ID, and you have a cell ID available in this. In 4G MME1, MME2 will have a tracking area ID list. It will have a tracking area ID as well, and it will have an EUTRAN CGI as well, cell global identity as well, your cell level information, this information. You have this information, it will have this information, it will have this information. All these three information at the location that is stored in the MME. And in your handset, you have your tracking area list, you have a tracking area ID. In 2G, 3G, you just used to have your routing area ID available. Okay. And this information is continuously being propagating from this cell. This cell is continuously propagating your tracking area list and tracking area ID to you. So if you change a location and tracking area ID to changes, you will update this tracking area information with you. And if you move to a different area, your handset is going to realize that, okay, the tracking area ID is changed, the cell ID and the tracking area list is changed. So then it will initiate their tracking area update procedure. Okay. Right. So here, once again, we will start with the attach procedure. Function of the attach procedure, the UE registers to the APS network similar to 2G, 3G. You need to perform registration, and then you need to have, you can use it at a services. A little bit of difference from 2G, 3G is that the always on IP connectivity for UE users is enabled by establishing a default EPS bearer during network attachment. So when we look into the attach flow, you will see that it is a combination of attach and create a PDP context request. Okay. Here in 4G, the terminology that we use is a bearer. In 2G, 3G, we use the terminology PDP context. So it's just an equivalent of PDP context. So here, since you are always on, for example, if you have a inside your handset, you perform a location update, you will get attached to your SGSN. Once you remove your data services are turned off, even in that case, you will be connected to the SGS, to your MME, because in 4G there is no connectivity with your CS core network. So whenever there is an incoming call or incoming SMS, you need to have a connectivity available with the MME to ensure that you receive the call to get call back or you receive an SMS. So it is an always on IP connectivity. And you have a default EPS bearer that is established during network attachment. The mobility management context and EPS bearer context will be created in MME and UE. The EPS bearer context will be created in SGW and PGW. Okay, so as part of your default EPS bearer, your mobility management will be just in UE and MME, and SGW and PGW and MME will have your EPS bearer context, the default EPS bearer context available. Okay, so this is the flow of your 4G attach. So you will send an attach request. Once again, this can be an IMSI and this can be your GUTI. And we discussed this, that in which case you send an IMSI, in which case you send GUTI is just like PTMZ. Okay. So based on your GUTI, if this is not available, your MME code, it will from GUTI is going to identify your MME code. So it checks that, okay, this MME code is not mine. So it will identify which old MME was serving this MSISDN previously. So it will send an identification request to the old MME and ask it to share the IMSI. If this MME has the context available, it will send the IMSI. If it does not have, then the MME is going to perform an identity request response to the MSISDN and ask specifically for the IMSI. Okay. And based on, once you have the IMSI, then you will perform your security function. The security function flow is the same as we discussed with HLR. You will send information to the HLR. HLR will respond back with your authentication sets. Your authentication sets, you are going to, part of those you are going to send to your MSISDN. MSISDN is going to perform the authentication. It will send the expected response over here. And the MME is going to compare the response received from HSS, the response to MSISDN. If it is the same, it will allow authentication. If it is different, then it will disallow the authentication, and then you are not going to proceed with your attach procedure, and you will get an attach reject message. Once this is done, you will proceed towards your update location. So this update location request is the same, similar. You will send your MME IP address, your MME GT. It will send, and based on that, if HSS has the old MME information, it will send, it will cancel the location of the old MME. get an acknowledgement, and then it will send an acknowledgement to your new MME that okay, your location has been updated and your the APN information and all that is covered in this. So your APN information and all the context information, the APN, your subscription information is then saved in the MME. Right. So in 2G, 3G, the attach procedure would terminate here. We will send an attach accept message and an attach complete message to accept message. But in 4G, it's an always on IP connectivity. So you will create a session with the SGW here as well as part of the attach procedure. So you will send a create session request to the SGW. SGW will send a create session request to your PGW. PGW will communicate with your OCS, check if it's if it has the quota available. It will communicate with PCR to check if there is any policy routing that need to be enforced. Internally, it will check that okay, this APN has been sent with me, so I have to assign some IP address. So based on all that information, it will check. It will assign a charging gateway, charging ID as well. So all this information is then shared in your create session response, your IP address, your quality of service information. We will have a little bit of an extensive look in what messages, I mean, inside this message, what content is shared. So this will come a little bit later. I have some slides available, and once we are done with the basic flows, we will look at the deep understanding of what content is. For example, if you ask me what is carried in the attach request, so we'll have a deep understanding of okay, what does the MSIGN sends an attach request? It sends an IMSI, it sends a GUTI, it sends all the quality of service information. So that we will cover in the later part of our training. Okay, so this is just this session is just for basic understanding of how the call flow works. So create session response. What you need to know right now is that it will have an IP address. This create session response is sent to the MME with the IP address and the charging ID, and then an attach accept message is sent to your MSIGN with the IP address. Based on that, your radio bearer is established between your MSIGN and eNode B and eNode B and MME. Then your attach complete message is sent. Based on your attach complete message, then you have a modify bearer request. This modify bearer request is to intimate to the SGW the IP address and the eNode B ID, because as I told you, there is a concept of DT, direct tunneling concept, that was introduced in 3G, and in 4G we already understood that MME is just involved for signaling. For user plane communication, it's always SGW that is communicating with eNode B. But in all of this flow, you will see that here nowhere eNode B is communicating with SGW. So in this create session request, the SGW will get the information of the MME. In this create session request, PGW will get the information of SGW and MME. It will know in any of these messages, you do not see that there is any eNode B information that is shared. However, for user plane communication, the SGW must communicate with eNode B. So this is where your modify bearer context request, your SGW will be informed of the eNode B ID and the IP address of the eNode B, and will inform that okay, for user plane communication, you need to directly communicate with eNode B. You don't need to involve MME in this. So you send a modify bearer request and a modify bearer response, intimating MME that okay, I have updated this bearer information. And after this bearer information response, then you can successfully perform your uplink and downlink information from your. So it will be from MSISDN to eNode B, from eNode B directly to SGW, from SGW to PGW, PGW ISP, and vice versa. If there is an already established, then why there is a separate default bearer activation procedure. Separate default bearer activation procedure, Yasser, is basically what happens is that your the bearer here between your That is basically a PDN connectivity request. Your question is correct. I think that is covered in the next, that will be covered in the session management part. Okay, so I will explain there that even if we have a default bearer, then why do we, because that flow is called PDN connectivity request. Okay, why do we need to have a PDN connectivity request once we cover this session management flow? Because just like in 3G, your bearer is, you have limited number of bearers available. Same goes for 4G. So after a specific time when you are not using at a services, part of your bearer, because you have an end-to-end bearer that is established with your MSSDN and E node B, E node B to MME, MME to SGW. So part of that bearer gets disconnected in order to ensure that you don't have unused signaling that is available for those handsets that are not performing any active browsing. So when you need to perform an active browsing, you need to send a PDN connectivity request in order to ensure that all of your bearers are established. So once we come to the session management, I will explain to you. We will proceed by explaining to you that okay, which portion of the bearer gets disconnected and which portion of the bearer is remains intact once you are not using any data services. So that is why you need to have an understanding of why there is a separate default bearer activation procedure. Okay, the E node B have the MME IP and S1 UP IP and S1 CP of MME IP, MME IP and the S1 user plane IP and S1 control plane of Azure, or the MME will send the S1 IP. Okay. The IP communication. Okay. Modify bearer. Okay, I will first answer this question. Modify bearer contacts user in order to inform the SGW that E node B is going to be communicating with you. I am not going to be communicating with you. Okay, so initial bearer was established between MME and SGW. Modify bearer is to inform that okay, the bearer has to be changed and now you will be communicating with E node B. Okay, so E node B has the MME IP. Okay, so the control plane IP, the E node B will have the control plane IP of the MME, and the user plane IP will be of SGW. Okay, and this, yes, the MME will send TS1 IP in this message. This one in the attach accept message. So basically this is going through your E node B. So in this, it will inform the E node B. So okay, your S1U IP is going to be of that of SGW. This is not going to be my IP. S1U is going to be this IP. The S1C, the S1 control plane is going to be my IP address. So MME is going to inform the E node B, and informing the SGW from here and attach complete. The MME will get the user plane and the control plane IPs of the E node B. And we will note that okay, control plane I will keep, and user plane I need to inform to the SGW the Rocky user plane is going to be the E node B IP address. So it is covered in this message number 12 and message number 14. Okay, and we will have a deep look into it when we discuss this signal flows in detail. Okay, what is the difference between default and dedicated bearer? The main difference, if you take a little bit of understanding of the word default and dedicated. So default is a default bearer. Whenever in 4G you get attached, you get a default bearer. It is going to be assigned to you by default. So any browsing you need to perform, any streaming you need to perform, that will be done on the default, and the default bearer will keep connected unless you get detached. Dedicated bearer is a bearer that is assigned to you for some dedicated services. For example, you need to use IMS. And why dedicated bearer? When we look into the quality of service, because a default bearer has a specific quality of service associated to it. You have a specific APN AMBR, you have a specific UE AMBR, a little bit advanced concept, you will come to that, but you have a bit rate, you have a GBR, you have an MBR, okay? So default bearer usually has the MBR, the MBRs, okay? You have your uplink MBR, you have a downlink MBR. But if you need to have a guaranteed bit rate, you say that, okay, I need to use a service in which I need to have a guaranteed bit rate. So default bearer does not allow you to have a guaranteed bit rate. It will give you a bit rate that is shared. You have an APN AMBR, you have a UE AMBR. So it will give you an MBR, the maximum bit rate, but it would not give you a guaranteed. So if you need to use a service where you need to have a guaranteed bit rate, in that case, then in that case, basically it is initiated from a network side. If you send a request and you say that, okay, I need to use this service and this service requires this guaranteed bit rate, then the network decides that, okay, this cannot be covered in the default bearer and I have to establish a dedicated bearer. Okay, so you can just understand this, that you have the formal commuting, you have a bicycle or a motorbike available, but for example you need to go to another country. Obviously you cannot go on your bicycle, you can, but obviously you're going to prefer to go by airplane. So if you put up a request that I need to go to another country, then your mode of communication is going to change. Your mode of communication is going to be that you have to travel by air. So you will have a dedicated where you need to travel and all that. So your specific service requirement calls for whether you can use a default bearer or you need to use a dedicated bearer. Okay. So default bearer is available at all time. Dedicated bearer is created when you need to use a service. When that service use is no longer used, your dedicated bearer is get de-established. Okay, so I explained this. This is just for the understanding of you people. You can read this afterward once I share the training slides, and then you can discuss with me if you have any concern regarding this. Okay, so this is a bit of explanation because this is a bit complicated, so I added this description as well. And once again, if you need to look into a little bit of detailed, you have the 3GPP documentation available. If you think that the reference documents are not enough, you just search that, okay, this flow and 3GPP, so it will give you in which 3GPP document is flow is covered, and then you can have a detailed understanding on that. Right, so the routing area update equivalent is your tracking area update procedure. So one is periodic tracking area update similar to routing area update. The other is going from one TLS to another TLS within the same MME. It is intra MME TAU. The second one is your inter TAU with SGW. Your MME is also changing and your SGW is also changing. So that is an inter MME TAU with SGW change. And the third one is changing one MME to another MME, but SGW remains the same. So there are going to be two procedures. This one is very simple procedure. No need to, if you understand this procedure and this procedure, you will be able to understand this procedure. So we will be discussing these two procedures. Hamza, yes, I will share this document after the training slide, after this training, okay? It will be shared. Okay, so with SGW, I think without SGW change, we can go first. That will be a bit easy to understand, and then we will go to with SGW. Okay, so you send a tracking area update request. You have GUTI available with you, and you have a TLS available with you. So based on that, your GUTI, the MME, based on your tracking area list, it will identify which tracking area ID, which old MME was serving you, and based on your GUTI, it will send that GUTI to the old MME and ask it for the context information. So the old MME will send the context, all the contacts available with it. It will send to the new MME. Then this is an optional security function, which will be done. And then you will send a context acknowledgement that, okay, I have received your context. Then your MME need to send to the SGW your modify bearer request. Here it needs to inform the SGW that okay, the old MME is now no longer communicating with you. I will be the one communicating with you. So modify bearer will have the new IP address of the new MME. And similarly, the SGW will inform the PGW the updated IP address of the MME. The PGW is going to send a bearer response acknowledging this, and then you have a modify bearer response message. Okay. And once your modify bearer response message is received, then you'll have the routine, your update location message. Your update location message is going to be sent to the HSS, where it will update the new the